this. Does anyone remember what a system is? You have a system of equations. Yeah, you have elimination and substitution. Those are the methods. But do you remember what a system actually is? It has to do with points. Yeah, it's where two or more lines cross. Okay? So this is two or more equations. So a system is two or more equations. And so typically when we deal with systems, we talk about where those two or more equations cross, and then where they cross is the answer. And when two lines cross, they cross at a single point. And so the answer would be a single point, so it would be written as x comma y. It would be written as an ordered pair. Does that make sense? Two lines crossing, the answer would be an ordered pair, x comma y. So when you learned how to do this, you learned 3 different methods. 2 of them were done kind of by hand. We call that algebraically, if you're like doing the computations by hand. And so the 2 methods by hand were elimination and substitution. And then 1 method was done on a grid, like on a graph, or with a graphing calculator, or with Desmos, and that's called doing it graphically. Okay, so that's what we're going to do on Monday. So if you're using elimination, your goal is to look at the x's and look at the y's and try to get one of them to cancel out. So try to get it so the x's are the same, or try to get it so the y's are the same so they can cancel out. So if I look at this, I've got a negative 5x, so if I could get this one to be a positive 5x, then they would cancel out. Or I could look here and say, oh, this is a positive 6y, so if I could get that one to be a negative 6y, then the y's would cancel out. So that's your goal with elimination, is just to get one of the variables to eliminate itself. Would you guys rather get rid of the x's or the y's? The y's. Okay. So, and it doesn't matter. In this problem, you can do either. It's going to be about the same level of difficulty. So if we're going to do the y's, I'm going to leave this one as a positive 6y. That means I want the other one to be a negative 6y. So how do I make a 3 become a negative 6y? What should I multiply it by? Negative 2. So I'm going to take the entire equation and I'm going to multiply it by negative 2. So negative 2 times negative 5x is positive 10x. Negative 2 times positive 3y is negative 6y. Negative 2 times negative 25, positive 50. Okay, so that's the first line. The second line I'm going to leave exactly the same. And now I'm just going to add them straight down. So 10x plus 1x, 11x, negative 6y, positive 6y, nothing, okay. 50 and negative 28, 22, okay. So now I have the equation 11x equals 22. What should I do? Divide by 11. X equals 2. Okay? So I know that with these 2 lines that cross each other, the single point where they cross has an x-coordinate of 2. So I know part of my answer, I just don't know the whole thing yet. Okay, so now I can take my x-coordinate of 2 and I can plug it into the first line for x, or I can plug it into the second line for x and solve for y. It doesn't matter which one I plug it into. This is where I get to be lazy. Would you guys rather plug it into the first line or the second line? Which one seems easier? Probably the second line? Okay, so I'm going to plug it in here. I always pick the one that seems the easiest. So if we're going to solve for y, what should we do next? Subtract the 2. Okay. So we have 6y equals -28 and -2?
30.
-30. Okay. And then what should I do?
Divide by 6.
Divide by 6. And so y equals -5. So the y coordinate is -5. Okay. And let's say I wanted to double check and make sure that answer was right. This is the one time today that I would be okay with using Desmos because our graphing calculators are not going to do this very well. Graphing calculators prefer for the y to be alone, which is not the case on here. So to check these answers, I'm just going to use Desmos real quick. Let's go to Desmos. So I'm going to graph both of these equations, -5x plus 3y equals -25, and x plus 6y equals -28, and I can see that they cross at the point 2, -5. So that's all we're doing. 2 lines, where do they cross? Okay, let's try the next one. So here, sometimes when you do elimination, it'll be like only the x would make sense to cancel out, only the y would make sense, and then sometimes either one of the variables you could do, kind of like this example we just did, the x's would have been easy to cancel or the y's depending on what you chose to multiply by. So sometimes there's no perfect right way to do it, sometimes there is a specific way you should do it. So here, if we look at the problem, you could cancel out the x's, you could cancel out the y's, whichever one you want to do is fine. So what would you guys prefer? X. Okay, so we've got a -10x. What could I do to the second equation to make this a positive 10x? Multiply it by a -5. Okay. So that's going to be positive 10x, positive 5y, 0. And then there's my first line. So I've got -10x, -5y, and 1. So if I put the x's together, what do I get?
0.
Yeah, 0 or nothing. If I put the y's together, what do I get?
0.
0. Okay. 0 and 1, if I put those together, what do I get? 1. Okay, so now we have to go back to yesterday. Yesterday I said if the variables disappear, you have to look at what's left over, and then that will tell you if your answer is all solutions or no solutions. So this answer is no solution. How do we know it's no solution? Yeah, this is false. Okay, this is false, so it means no solution. Okay, so when I graph this on Desmos, what am I going to see from my 2 lines? They're not going to cross. So when we have 2 lines, if the answer is no solutions, it means those 2 lines will not cross each other, which means that the 2 lines are what? Starts with a P. Parallel. The 2 lines are parallel. They're never going to cross each other. There's no solution. So let me go ahead and graph these so you guys can see it. So we have -10x minus 5y equals 1. There's the first line. And then -2x minus y equals 0. There's the second line. They are very close together, but they do not cross because they're parallel. Okay, let's try the next one. All right. Do you guys want to get rid of the x's or the y's? The y's. Okay. So we have a negative 8y and a positive 4y. What do I need to do to take the positive 4y and make it positive 8? Multiply it by 2. So if you notice, I always look at the one that is smaller, and I want to make it the same number as the bigger one, but just the opposite sign. So if the other one was negative 8, then I want to make the smaller one positive 8. If the other one was positive 20, then I want to make the smaller one negative 20. All right, so I'm going to do 2 times 3x, I get 6x. 2 times 4y is 8y. 2 times 7 is 14. Does anyone have any predictions here? It's going to be all solutions because why? Yeah, the equation's going to be true. We're getting everything to cancel out here. 0, 0, 0. That's a true statement, which means all solutions. So if we were to graph this, what would we see? The lines overlap. I'm going to graph the first line, it's going to be graphed. When I graph the second line, it's going to go right on top of the first line. Okay. All right, how do we feel about elimination? We're good? We got it? Okay. All right, next we have substitution. So substitution can go 2 different ways. So, and I did an example of each. So one method of substitution is where they have the same variable isolated. So they said if y equals this stuff and y equals this stuff, then the stuff must equal each other. Does that make sense? Okay. So if y equals this and y equals that, then the 2 things must equal each other. I can just ignore the y's. So negative 4x minus 13 equals negative 3x minus 9. It doesn't really feel like you're doing substitution because all you did is get rid of the y's. All right, so to solve this equation, what should we do? Okay, so we can start off by adding the 13 over to the other side. So negative 4x equals negative 3x. That's 4, okay. So if my 4 is over here, where should I move all my x's? To the other side. So the 4 is on the right, I'm going to move my x's to the left side. So how do I move a negative 3x? I'm going to add it. Add 3x, okay. Negative 4x, positive 3x, negative 1x. And then how do I get the x alone? Divide by negative 1. X is negative 4. Okay, so the x coordinate is negative 4. We still need the y coordinate. If you have the x coordinate, how do you find the y coordinate? Plug it back in for one of the x's. Doesn't matter which one, you get to be lazy. So which one would you guys like to plug it into? The bottom one. Numbers are smaller. So I'm going to say y equals negative 3 times my x value minus 9. Negative 3 times negative 4. Positive 12. 12 minus 9. 3. Okay, perfect. So this one, because the y's are alone, we could graph this one on Desmos, or we could graph this one on a graphing calculator. I'm going to go ahead and do this one on the graphing calculator because it's something we haven't done yet. So let's go ahead and type this in. This will be new for us. So I'm going to hit the y equals button right here. And I'm going to press clear to get whatever the last class did off the screen. So there's the clear button right there. And our first equation is negative 4x minus 13. So you have two little minus buttons on your calculator. This right here is a negative. This right here is a minus. So however you were to say it out loud, that's how you type it. So when we read this out loud, we say negative 4x minus 13. That means you use each button once. Negative 4x minus 13. So I'm going to type in negative 4x minus 13. All right? So negative 4x minus 13. The x button is right here next to the green button. Okay? Negative 4x minus 13. When you type in the negative, it is a little bit shorter than the minus button. So negative 4x minus 13. We good with that? Okay. And then we've got negative 3x minus 9. So to go down to the next one, you can press enter in the bottom right corner, or you can press the arrows. So negative 4x minus 13, negative 3x minus 9. We all good? Okay. And then once you're done, you can hit the graph button right here. All right, once you have that, to be able to see where they cross, we're going to calculate. You guys see how it says calculate in blue? So we're going to use the blue button to calculate. We're going to hit second trace, which is where the calculate button is. And we want to find out where the two lines cross each other, where they intersect. I'll help in a little bit. So we're going to go down to number 5. So second trace, number 5. Second trace, number 5. All right, and then once you do that, you can just press enter, 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 and it will tell you what the answer is. Enter, enter, enter. Negative 4, 3. Should confirm that you got the right answer. It's a lot easier on Desmos, but you can't use Desmos in honors math classes after this. So that's why I want to make sure we can use our calculators. Okay, were you guys able to find it? Okay, and I'll come look at yours after this. Okay, all right. We good? Okay, so again, that was second trace, number 5. And I pressed enter, enter, enter. Okay, cool. Let's try the next one. So the next one is more like a true substitution problem where it has one equation with the y actually by itself and then one equation where the y is just inside the equation. So what I like to do is I look at the equation that has the variable inside of it, and I'm going to circle it right here. So go ahead and circle the y inside. We can see that here's the y alone. And there's the y inside, so that's where we're going to substitute something inside. And now I'm going to write that equation out. Negative x minus, and where I had the circle, I'm going to put parentheses, equals negative 4. So negative x minus, and where the circle is, I'm putting parentheses, equals negative 4. Everybody have that written? And now where the circle was, that's the y, I'm going to take the other equation and I'm going to substitute it into the parentheses. So the y represented 5x minus 20, so I'm going to substitute 5x minus 20 into the first equation. Now, since I had a minus with parentheses, what should I do with that minus? Distribute it. Okay, so we're going to distribute. So I still have the negative x, and then what do I have? Minus 5x plus 20. Okay. And then what can I do with this equation? Yeah, so we have a negative x and a negative 5x. What does that give us? Okay, negative 6x plus 20 equals negative 4. We want our x to be alone. So what should we do now? Subtract the 20. Okay. So negative 20 and negative 4, negative 24. And then, and so x equals 4. Okay? So we know the x-coordinate is 4. How do we find the y-coordinate? Plug in the 4. Does it matter which one you plug it into? No. Which one do you guys want to use? The bottom one? Okay, so we're going to do y equals 5 times the x value minus 20. What's 5 times 4? So we have 20 minus 20 is 0. Okay. All right, so the last part at the bottom, remember the solution to a system of equations is a point and should be in the form x comma y. The instructions tell you to use elimination, substitution, or graphing. I do not want you to use graphing, so scribble that out. Only use elimination or substitution. All right, and then I did not print the instruction sheet because it was a whole nother sheet of paper, but I'm going to read you guys the instructions because it's very exciting. All right, this is a bank robbery activity. So look, a bank was just robbed by this dude. Doesn't he look menacing? Are you guys impressed? I'm not going to say it's because of the red hair, but that's why he looks so menacing. Because he's fierce, you know? You know what I'm saying? All right. A bank was just robbed by 3 men. All 3 men look like this. Exactly like this. No? Okay. You are a police officer on the force for 10 years. You started when you were, how old are you now? You started when you were 5, or 6, or 7, or 8. All right. You've been called in to look for suspects. It is up to you to follow the suspect's trail and track them down. In order to do this, you will need to solve 10 problems involving systems of equations. You guys don't really seem like you're into this. It's a little bit hurtful, but it's fine. Okay, so you have to solve the problems in order, okay? That's important. You have to solve the problems in order because if you go out of order, then it can mess up the way that this works, okay? If the solution lands on a building, so go ahead and take your paper, flip it over. When you are done completing a problem and you graph that problem, it will land somewhere. So maybe it'll land like out here and it's like not on a building at all. Then you just know that the robber did not go there. Okay? But if you're doing a problem and it lands like right in here, then you go like, oh, the robbers went to the zoo. So you know that they like went to that place. Does that make sense? Okay. So if you land on a building with your solution, then you know that they went to that place. If you don't land on a building, then you just know that for that solution, they didn't go to a specific place. They were just like driving down streets or something. Okay. They went to 4 locations, okay? So you can see that on the back. First location, second location, third location, fourth location. When you write down the answers for this, you're not going to be writing the coordinates. You're going to be writing the name of the place where they landed, okay? The last location is where the suspects are located at the very end, okay? They started, or they robbed the bank at 8:52 a.m. We're trying to figure out where they are at the very end. And to do that, you have to add up how long they were at each location, okay? So the way that you add up how long they were at each location is you add the amount of time for each of the coordinates. So if the coordinate was -5, 10, you would just take the absolute value of each of the numbers. So -5, 10 would be 15 minutes. 5 and 10 is 15. -2, -11 would be 2 and 11. That's 13 minutes. Does that make sense? So you ignore the negative sign and just add the numbers together. And then you say, oh, that's how many minutes they were at that location. Okay? So that's how this works. So the important thing is you do the problems in order, and then you write down which location they went to first, then second, then third, then fourth. And whatever the coordinates are of that location, that's how many minutes they spent at that location. Does that make sense? Okay. So what we're going to do is we're going to write down on here, we're going to say that they were at the bank at 8:52 a.m. Okay? If they were at the bank at 8:52 and they went to those 4 locations, where do you need to be at the last location? What time do you need to be at that last location so you can capture them? Okay? Maybe they were at the first location for 5 minutes, the second location for 7 minutes, the third location for 12 minutes, the fourth location for 68 minutes. So you need to be at that last location at 9, blah, 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 to be able to catch them. Does that make sense? Do we kind of understand how the capturing part goes? Okay. If you don't figure that out, the very least I want you to do is actually do the 10 problems. Sound good? We can do that? Okay. All right, so go ahead and get started on that. Let me know if you have any questions, and I'll help you.